Good morning, good afternoon, or good evening. This is going to be a walkthrough of the new November 2020 1H paper. Now, this is as much as possible a blind workthrough. Most probably I have seen some of these questions before, but I haven't prepared anything. So I hope to give you a first look appearance, a first look thought as we go through this paper. Of course, whenever you start one of these papers, certainly in exam style conditions, it's worth just double checking, reading through the front, making sure you have everything available in front of you. Black ink is the normal these days, fill in the boxes, etc. Calculators might be used. I've grabbed mine off to the side. I'm ready to go. 100 marks, 2 hours, means we're roughly working at a mark a minute. Slightly slower than that is fine. So let's get going straight away. There's our formula sheet, worth knowing what's on it. But question 1, a set theory Venn diagram question. We want to list the members of A intersect B. Well, that was and. That's asking for the members which are in A and in B. So that's the middle section. You don't have to put them in order, but it's convention to do so. Because it said list, we don't need to put the set brackets round, but I'm going to do so anyway. List the members of B dash. Well, that little dash means not, so we're looking for all of the elements which are not in B, and I'm going to try and put them in order. A little more challenging this time because they're all over the place, but I believe so. That's 5, 7, 8, 9, 10, 11, 13, 14 are all the things which are not inside the B circle, so that is not B. A number is picked at random from the numbers in the Venn diagram. Find the probability that's in set A but not in set B. So we need to be inside the circle A but outside the circle B. Well, that's these three options. You've got the numbers 1 to 14, so that's 3 good things out of 14. Double check that can't be simplified. No, it can't, so we're sorted. Question 1 done. Question 2. Toy cars are made in a factory. They're made for 15 hours each day, and 5 cars are made every 12 seconds. The probability of being faulty is 0.002, and we want to work out how many faulty cars. Well, let's first try and find out how many cars in total are being made. Well, let's build it up. So 12 seconds is 5 cars. Well, we need to get to 15 hours for the day, so let's go to 1 minute first. Well, there's 5 sets of 12 in 60 seconds, so that's 5 lots. So there are going to be 25 cars in 1 minute. So 1 hour, 1 hour, 60 minutes in an hour, 60 times that, 25, gives us 1,500. And then finally, in 1 working day, in those 15 hours, times that by 15, and we're getting 22,500 cars in a day. Well, we wanted to know how many faulty, and we're at a rate of 0.02 to find failure rate. So if I multiply that by 0.002, that's giving me 45 faulty per day. 45 out of 22,500 isn't too bad of a rate. Question 3. On the grid, we'll draw the graph of. Now, there are lots of ways to do this question. My preferred is just by abusing y equals mx plus c. That's my c. That's my m. Now, the m is the whole of the -4. Now, you could draw yourself a little table of values. I find the table of values to be just a little bit slower. So we have our 7. So I'm going to start at 7 on the y-axis being my y-intercept. And that -4 is telling me for each 1 across, I go 1, 2, 3, 4 down. Now notice I didn't go 1 box across, I went 1 relative to the scale. Now you'll have a ruler. I'm going to put 1 more back there as well, counting backwards. So your joining up will be a lot nicer than mine. I'm actually going to plot a few more points to make sure that I'm not terribly off when I join these with a very freehand line and I curved off at the end. Of course, pencil and ruler, much better idea than trying to do it on a tablet. Question 4. Here we have 6 numbers and they're written in order of size. That's actually an important thing. The median is 9. Well, 9 then is in the middle here. So if 9's in the middle, that's telling us straight away the middle of x and 10 is 9, so x has to be 8. The mean is 11. Well, that tells me if I add them all up and divide by 6, I get 11. So 4 plus 7 plus, now we know 8 plus 10 plus 2y's all over 6 is going to equal 11. A bit of simplification there. Let's multiply up by 6. Let's simplify that side. I think that's 29. Is that right? I'm going to double check that on my calculator because I don't like the fact that it's coming out as being an odd number, but it is 29. Double check I haven't written down anything wrong. Really useful to continually be checking yourself. If something doesn't feel right, like that didn't feel right to me, to double check that you haven't obviously done something wrong. And we get our answers there. So x is 8, y is 18.5. No reason why y can't be a decimal, why it can't be a whole number. That did feel a bit odd, but nothing wrong with that. Question 5. Right, 5.7 times 10 to the negative 3 is an ordinary number. A negative power means we are a 0 point something number. I'm going to start by writing my 5.7 and I'm taking 1, 2, 3 steps back. So that's where my new decimal place is and just fill in the gaps. 0.0057. 800,000 in standard form. Pick a number between 1 and 10, which is going to be our 8. And then count how many decimal places you had to have moved. 1, 2, 3, 4, 5 times 10 to the 5. Work out that thing. Now you can do this with non-calculator techniques, but we have our calculator. It didn't tell us to show any working, so I'm going to type exactly that into my calculator. Now unfortunately, our calculator has given my answer not in standard form. If the question's in standard form, you have to give your answer in standard form. So my number between 1 and 10 this time is 4.55 times 10, and there's 1, 2, 3, 4, 5, 6 steps this time. 4.55 times 10 to the 6. It is worth recognizing that 10 to the 6 is in the millions. So this is exactly in the millions. Question 6. A rocket is traveling at that speed. We want to work out how long it took the rocket to travel, but in seconds. Okay, I've got a couple of choices here. I can work out my time in hours first, and then convert it into seconds, or I can try and convert the speed into kilometers per second, and then do my speed distance time calculation. I think the first of those is probably more sensible. So speed equals distance over time. We're looking for time. So rearranging that formula is distance over speed. Oh, that's already the wrong way up. So distance over speed, we're going 100 kilometers at a speed of 28,440. My calculator is going to give me that number, and already I can foresee that this is going to be small. This is a very fast rocket going quite a short distance. So 0.0035 hours is not really a useful metric. So let's convert it into seconds. So to convert into minutes, we times by 60. To turn into seconds, we're going to times by 60 again. So I'm just going to times by 60 squared. And that will get me into seconds. And that's coming out as so. Again, I'm going to write down for the examiner a lot more decimal places than the question actually wants, so they can see my working and then give my final answer correct as they requested to the nearest second. That's question 6 done. Question 7. This is our core algebra question. Lots of parts, lots of basic algebra skills. Solve that. Whenever I solve equations, I like to deal with the thing I don't like first. I don't like this bracket, so I'm going to expand it out. Timesing both parts by 5, as so. I now don't like x being on both sides. And if you remember from hints, you should normally move the smaller amount of x. A bit of a trap here, the smaller amount of x is that negative 5x rather than negative 3. Adding that to both sides, as so. Deal with the 7 and subtract the 7 from both sides. Again, I'm getting a decimal answer, not wrong, but worth checking. And now I've got my answer, I can sub it back into the original to see if it actually works. Sub in to check. So I'll do that in my calculator. 5 lots of 4 minus 6.5 comes out as negative 12.5. 7 minus 3 times 6.5 also comes out as negative 12.5. That equation works for my 6.5. I've got that right for sure. Carrying on. Part B, we need to factorize fully. So we need to take out the biggest possible everything from this equation. At first glance, I can see a common factor of 4, but at a second glance, I can also see that both of these are in the 8 times table. 8 is bigger, 8 is our highest common factor, so let's use that. I can see that I've got an m squared in both and a g cubed. So let's see what's left over. From the first term, we've got a 2. 2 times 8 makes a 16. We've got an m left over, and we've taken out all of the g's from that term. The second one, 24, lose the 8 is 3 left over. We dealt with all the m's, and we've got a g squared once taking the g cubed out. Double check that there's no common factors for the 2 terms in the bracket, and we're done. Part C, we're now into quadratics. Factorize that. I'm looking for 2 numbers that multiply to negative 48 and add to negative 2. Well, 48 is in your 8 and 6 times table. They definitely have a difference of 2. To make the difference the sum negative, we need to choose negative 8. So therefore it's y minus 8, y plus 6. Does not matter which order you write the 2 brackets in, as long as you have the negative sign with the 8. You can expand that out with FOIL as well. Check that it does indeed get back to where you want. Hence. Hence is probably my favourite word ever used in maths. Hence means use what you've just done. So whenever you see the word hence, you should immediately look back. How does the previous part of the question link to this part of the question? And the previous part was we've already factorized this. So hence solve, we need y equals, from the first bracket y equals 8, from the second bracket y equals negative 6. Question 8. We have a 10-sided polygon. We want to try and work out the value of x. Well, there's something a little bit easier than finding the value of x, which is actually finding the interior angle here. I have every other angle, and I know that the total interior is given by the formula n minus 2 times 180. In this case, 10 minus 2 times 180. My total interior angle is 1440. So that angle there, I'm going to call it y just to keep up with it. So y plus the rest of them, which I'm going to add up in my calculator. I'm not going to write all of them down. That's 168 plus 150. I'm going round anti-clockwise. 34. There's some symmetry here which I noticed, which may have been able to abuse. We've kind of got those two match, those two match, those two match, and those two match. That might be a good way to check your work afterwards. But I'm coming out as 1302. So y equals, subtract that off the 1400, 138. That looks like it could be 138. It doesn't seem entirely unreasonable, although it is not drawn to scale. It's at least an obtuse angle, which is definitely what I'd expect. X then is 360 minus that value, 360 minus the y, which comes out as 222. A nice symmetric answer. And as I said, you could probably add those up in another way as well to check your calculation. Question 9. In a sale, normal prices are reduced by 20%. A bag costs that much in the sale. So this is we want the normal price. So this is actually a backwards question. From the normal to the sale, we've got 20% reduction. A 20% reduction is a multiplier of 0.8. In the sale, we're 1080. Going backwards then, we're dividing. Don't fall into the trap that the opposite of a reduce is an increase. It is, but not of the same percentage. Our answer there is 1,350 rupees. We do have to do the division for these back in time style problems. Highest common factor of two incredibly large numbers. These powers, 3 to the 43, 3 to the 37, are absolutely massive. So doing any kind of tree diagram or factor tree will be incredibly challenging. I am going to do something a little bit to B, and that is to rewrite that 16 as 2 to a power. So they're actually a product of prime factors. The highest common factor then, well, if you think about your Venn diagram, what you would put where, we have exactly 1, 2 in common, and we're going to end up having 37 threes in common. That's quite a lot of threes. Now, if I were to type that into my calculator, it will come out in standard form, absolutely horrendous, a times 10 to the 17 style thing. So I'm not going to actually work that out as a proper number, and I'll leave that as my answer. It is only a 1 marker, so that's fine. Express A times B as a product of powers of its prime factors. Well, here's where the rewriting 16 is actually going to help us a lot more. Because now this is just an indices question. We can add the powers of the two separate parts. And the product is 2 to the 5 times 3 to the 80. Absolutely massive. Question 11. We're coming up to the middle of the paper. We're coming up to that securing the 7 style part of the paper. Question 11. We have a trapezium where we have BC and AD parallel. We've got some sides. This has exactly one line of symmetry. That's quite useful. That's telling us that AB is the same as CD. These two sides are of equal length, and we have an area of 179.4 centimeters squared. Work out the size of the angle ABC. So we want this whole angle up here. Okay, a couple of different ways to do this. Maybe the simplest, at least the first thing I spotted, was if I can find this height, then I have a triangle AB, and I'll call this point down here E, and then I can work out an angle in that triangle using a bit of symmetry and such, and then I will just add on the 90-degree right angle there. So first, to try and find that height, well, let's use the area. The area 179.4, well, the area of a trapezium is half the sum of the parallel sides. So let's add up those two, put a half in front, times the distance between them, which in this case is the height. 8.4 plus 17.6 divided by 2 comes out as 13, so 13 times that height is the value given, so you can work out the height as 13.8. Okay, so now let's have a look at that ABE triangle that I mentioned. So we have our ABE. We now have the height is 13.8, but it's this bottom side that we need to be careful about. And this is where the symmetry, the fact that we've got one line of symmetry comes in. We have a little bit here. We have the same amount over here. And this bit in the middle is also 8.4. So that's telling us that that 17.6 on the bottom is the 8.4 plus the 8.4 plus 2x. So let's solve that. Let's subtract off the 8.4 and divide by 2. So that side there is coming out at 4.6. So now we have two sides of a right angle triangle. That means we're allowed to use SOHCAHTOA. It was this one up here that I wanted. So we have our opposite and we have our adjacent. So tan of the angle is the opposite over the adjacent. So theta comes out as tan inverse of that value. Tan inverse of 4.6 over 13.8. And my calculator's telling me that angle's 18.4. Do I believe that? Yeah, this is quite a skinny triangle. I do expect that angle to be quite small. But the question wanted ABC. And as mentioned right at the beginning, we're going to add 90 to that from the method we've described. So that's 108.4. Really, I should have wrote more decimal places first. This is to 1 dp. I will, for the examiner, put a few more decimal places in here, just so that they can compare the numbers, the working method, to the mark scheme more easily. 108.4 seems reasonable for that kind of shape. Question 12. Simultaneous equations. Nothing special, nothing fancy about this question, just a nice normal simultaneous equations. I like to label my equations so I can tell the examiner exactly what I'm doing at every point. I could try and kill the x's, but the y's look nicer. I've got one positive, one negative, which makes my life easier when I come to eliminate them. So I'm going to multiply the top one by 5, making sure that I do multiply every single section by 5, as so. And the second one, I'm going to multiply through by 2. This is going to make the y's match up. And that's a -6, let's not lose the negative sign. And now if I add the two equations, stuff cancels. 41x, those disappear, is 154. Nope, 164. Dividing through, and I'm hoping this comes out as a whole number. 41 is prime, is incredibly nasty. So if this didn't come out nicely, I would have been sad, but it was absolutely fine. X comes out to be 4. And now I can sub back into one of the originals. I'm going to go back to equation 2, because the y term is positive. 3 times 4, so that's 12 plus 5y equals -3. 5y is then -15, and therefore y is -3. And that is my pair of solutions. I'm going to mentally check it still works in 1. 7 times 4 gives me 28. minus 2 lots of -3, that's subtracting off -6, 28 plus 6 does give the 34. Those two values work in both equations. I know they are correct. Question 13. Jan invests 8,000 in a savings account. It pays a compound interest of X per year. It doesn't tell us what that compound interest rate is. So I'm already thinking, what's my formula? How do I do it backwards? At the end of 6 years, we have that value. So remembering our formula, it was 8,000 times the multiplier, which we don't know, so I'm just going to call it m for now. So the power of the number of years gives me the value at the end. So I have that calculation. Well, let's undo that. Let's divide by the 8,000. And that will give me my multiplier to the power of 6. And then we're going to have to use the 6th root. So we have to use the calculator button, which looks like that, to put a 6 as our root and our answer as the other value, and that comes out as 1.175. And one thing that you'll notice in your calculator when you do this is if they've planned the question well, you get lots of zeros. So this is incredibly close to 1.0175, and the error is so small. So that's a really positive sign to me that we've probably done the right thing. Now, of course, this is the multiplier and not the interest rate. So we need to convert this back into that interest rate. Well, thinking how you would turn the interest rate going forward, you'd add it onto 100 and then divide by 100. So going backwards, this is telling us this is 101.75% of, which is therefore a 1.75% increase. So that X is 1.75. And again, you can do this question going forwards with that answer to see if you get the value of 8,800 to give yourself that pat on the back to know whether you've got it right or wrong. Question 14. Inverse proportion. These proportion questions are very similar every year. They can throw curveballs, but rarely. F is inversely proportional. So F is proportional to, inverse means 1 over the square of V. 1 over V squared. That's all that first question's told me. Well, I want to actually turn that into something useful. So we change the alpha symbol, the proportionality symbol, into equals K. For inverse, we can just put that K on top. Let's use the given condition. F is 6.5 when V is 4. 6.5 equals K over 4 squared. Therefore, K, if we multiply up 6.5 times by 4 squared, K is 104. The question wanted a formula for V in terms of F in terms of V. So that has to be an F equals, and the only other letter I'm allowed to use is V. So I need to replace that K. I'm looking at this line up here. I'm going to replace that K with what we've just worked out to be, put the V squared on the bottom. Make sure it is F and V. I see a lot of people putting the 6.5 and the 4 in those slots. That's not a formula. That's just a calculation at that point. But there's our answer. 15, probability. We have two fair spinners. So the fact they're fair means each of these sections has a 1 in 5 chance. We're going to spin each once, and we're going to complete the tree diagram. For spinner A, I've got 2 red sections. There are 5 sections in total. Because it's fair, 2 out of 5. Green, 3 green out of 5. Those two should always add up to 1. Indeed, they do. Spinner B has 4 red and 1 green, 4/5 and 1/5. Filling all that in, ready to go. Work out the probability that at least one will land on green. 2 ways to do this question. One is just do it. 2 is a bit more sneaky. So I'll do the first method and say a little bit about the second. at least one will land on green. So that means we have to work out green, 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 red, or red, green. Now green, green is along the bottom of my picture, 3/5 times 1/5. Green, green is 3/5 times 1/5. 3 out of 25. Green, red is 3/5 times 4/5. 3/5 times 4/5 gives me a 12 over 25. And finally, red, green is 2/5, 1/5. 2/5, 1/5, that's an extra 2 out of 25. So our total is going to be 15, 17 out of 25. And that's my answer. Alternatively, you can notice that at least one means the opposite, so not both red. If you're at least one green, then you're not both red. So you could have also worked out that probability as 1 minus red, red. I said I'd only talk about it, but I'll fill in the working with this far. Red, red was 2/5 and 4/5. So that's 1 minus 2/5 times 4/5. That's 1 minus 8 over 25, which is 17 over 25. And you'll notice our two answers match. I needed to do a lot less flicking backwards and forwards for that second method, but I did have to think more carefully and have a stronger understanding of these probability terms. Whichever method you prefer works. The second method is more likely to be useful for the questions 22, 23, 24, if there's a probability style question that late in the paper. Question 16 are circle theorems. We have points on a circle, centre O, and the angle labelled. Find MLP and give a reason. Well, we have what's called a cyclic quadrilateral here. L, M, N, and P are all on the circle, which means we can use our cyclic quadrilateral, which means these two angles add up to 180. So that angle there is 122. From 180 subtract 58. And the reason, opposite angles in a cyclic quadrilateral add to 180. A few words that you have, well, pretty much you have to have at least that statement. You can add more words to it, but they're the kind of key parts that the examiner will be looking for. Find the size of the reflex angle, MOP. So wanting this angle round here. Now this is our arrowhead idea. So you could either use the arrowhead, that's a very thick highlighter, arrowhead going that way to find the angle on the opposite side, 360 minus, or use the weirdly shaped arrowhead, which looks more like a diamond, in that direction using the angle we've just created. So I'm going to use that one because it's one less step of working. So the reflex MOP is twice MLP, so that's 244. The angle at the center is twice the angle at the circumference. Of course, it didn't ask for the reason there, but it's worth having that in your head just in case they did. Question 17. This is a bounds question, actually. I can see straight away that there's bound in the question somewhere. A metal block has that mass to nearest 50 grams. Block has the volume correct to 3 sig fig. And we want the upper bound for the density. A couple of things I need to remember then. So density equals mass over volume. And let's also work out our bounds. So our 5 kilogram mass, well, I like to think about this on a scale with that level of accuracy. So the 5 kilogram mass, the next scale point is an extra 50 grams higher Being careful with 50 grams being 0.05 and 4.95, going down a step on my scale. So my lower bound for that is halfway between 4.95 and 5. Add them up, divide by 2, and then similarly on the other side. Lots of ways to calculate those bounds. This is the image I have in my head. The volume of the block is in standard form. That's quite awkward, but it is rounded to sig fig, which actually makes it a little bit nicer. So here we have our 1.84 times 10 to the negative 3. In terms of my scale, the next step up to 3 sig fig would take us to 1.85 and down a step 1.83. So my lower bound is halfway between the lower two scales, and my upper bound is halfway between the upper two scales. Now, of course, I probably didn't need to know all 4 of these bounds, but I like to get them down just because while I'm thinking about it, it doesn't require that much more. So now I want density, I want the upper bound for density. So if I want this to be as dense as possible, I need to have the upper bound for the mass. It wants to be as heavy as possible in the smallest amount of space. Big mass, small space means big density. So my upper bound for my mass is a 5.052. Lower bound for volume. And this is why I like to have them all set up. I don't need to go forwards, backwards. I can think about one thing at a time. Typing that into my calculator, I'm getting my density as so. Again, I'm going to write out way more than is needed. Look, back to the question, 1 dp is what the question actually wanted. So it's 0.4. Check units, kilograms per meter cubed, which is actually already on the answer line ready and waiting for us. That seems reasonable. Times 10 to the negative 3 is small. So this is not the largest block. It's got quite a lot of mass. 5 kilograms in that small of a space is going to have quite a high density. So I was expecting quite a big number answer. Question 18. Our histogram. This was either a histogram or a commutative frequency with this kind of setup. Turns out to be a histogram. So histogram, I need to remember the extra column that I add, which in this case is frequency density. So I want the frequency density for each of these. Remember, in the formula is the frequency divided by class width, how wide the column is. So here the width is 10, so it's 35 divided by 10 for the first one. The width here is 15, 45 divided by 15. Width is 15, difference between 50 and 35. 75 divided by 15. Width of 20. And finally width of 10. Incredibly nice numbers, actually, to try and plot on my scale. So I notice I need to get all the way up to 5. Well, it looks like I can go 1, 2, 3, 4, 5, and that fits really, really nicely. So between 10 and 20, I have a box of height 3.5. And with a ruler and pencil in your real paper, you'll be able to draw this a lot neater than I can. Between 20 and 35, I've got a height of 3. So 20 to 35, height of 3. Height of 5, between 35 and 50. Between 50 and 70, this is going to be a long bar, is a height of 20. Sorry, a height of 2. And then finally, between 70 and 80, I want a height of 8. So I'm going to zoom in to make sure I get the right bar. And voila. Now this was only part A, so let's see what part B has to offer. Work out for the an estimate for the number of these plants with a height greater than 40 centimeters. So where's my 40? My 40 is here. So I want an estimate for the height, for how many For me, the most important thing for a histogram is frequency equals area. So if I'm asking for how many, I'm actually asking for the area above that point. Well, the area above that point, we already know this box's area 40 and 8 because they came from the picture. This then is a base of 10 with a height of 5. There's an extra 50 here. 50, 40 and 8 gives us a total of 98 plants with a height greater. It's worth noting why it said estimate. The fact it says estimate is just because we have assumed that in this 35 to 50 bar that they are spread fairly in that bar. It could have been the case that all of those 75 plants, could have been all of them were above 40. But we've assumed they're evenly spread, so only 2/3 of them are actually above 40. Question 19. At the start of that question will spring fear into a lot of students. Without using a calculator, rationalize. Now you can cheat little bits. You can do little parts of the calculation without with your calculator. However, you need to convince the examiner 100% that you are able to have done it without. So he can't skip any unreasonable steps. Rationalize the denominator. We're going to times top and bottom by the denominator, but with the sign swapped. I'm then going to expand out the top. 18 plus 6 root 7. And I'm going to expand out the bottom slowly to really show the examiner I know what I'm doing. We have our 3 times 3 is 9. We've got plus 3 root 7. Subtract the 3 root 7 plus the root 7 times root 7. Now I can simplify. Again, I'm going to try and do it a little bit slowly so that I'm not making any unnecessary jumps. And I notice that there's a common factor throughout. Everything is even. So I'm going to divide everything by 2. And we're done. Of course, there's nothing stopping you from typing it into your calculator either at the beginning or the end to check you've got the right answer. And I seem to have done something wrong. And I have. So I've checked in my calculator and I've realized I've made an error somewhere. And from the calculator, I now know what the right answer is. And I also spot the mistake, which is this last term over here. It wasn't root 7 times root 7, it was negative root 7 times root 7. So that's a subtract 7 rather than a plus 7, which means my denominator is 2, which actually makes my simplifying a lot easier. Just shows the importance of having some way to check your working. You can spot your errors fairly quickly. Question 20. We're coming into the proper meat of the questions now, the last few. We have two similar shapes. R has surface area and volume. S has surface area. Work out the volume of S. Well, this is going to be manipulating our different scale factors. So firstly, let's work out the area scale factor. I always do the big one over the small one. So this is going to be my area scale factor going from R to S. 300 divided by 108 in my calculator comes out as 25 over 9. Now that's my area scale factor. I want volume. The way we go from area to volume, we have to go via length. So my length scale factor is the square root of that thing. And it's actually quite nice because both the top and bottom are square numbers, 5 over 3. Our volume scale factor then is the cube of our length scale factor. So let's cube both of them. We get 125 over 27. And finally, let's actually do the calculation. So the volume of S is the volume scale factor times by the volume of R. 135 times 125 over 27. Type that into our calculator. 125 over 27 gives me an answer of 625. Good sign that it was a whole number. Okay, it doesn't have to be, but it's always positive when it is. It was also exact, question didn't tell us to round, another good sign. Question 21. That looks nasty. But it's just algebra. We need to simplify this fraction. The hint whenever you see a question like this is step 1, factorize everything. I'm going to leave that 7 over x minus 1 at the end. That'll be the very last thing that we manipulate. Let's factorize everything. The top, I recognize, is a difference of 2 squares, which means it factorizes into the thing plus and the thing minus. I had to use 3x to make the 9x squared and the 2 squares to the 4. The denominator. And now you can go and factorize this properly from scratch. However, you can also cheat quite a lot. To cheat, notice what kind of answer I'm expecting. I'm expecting these brackets to cancel. I can already see, and I'll already cross out, the 3x minus 2 and the 3x minus 2 already cancel. So wouldn't it be convenient if the denominator here had a 3x plus 2 to cancel as well? Well, let's see if that works. Let's try and build from that. Well, with the 3x, I need to have an x to make the 3x squared. So that term's done. To make the negative 10 with the 2, I need a minus 5. So that term is done. Now, the problem with this technique is you haven't guaranteed this is correct. You have to check the middle term. Well, here I have a negative 15 and a plus 2. That does give my negative 13 in the middle, so I do indeed factorize as so. A really sneaky trick that you can use just because you know it's an exam question and you know it has to be relatively pleasant. We then notice the 3x plus 2's do indeed cancel. Before I do anything else, I'm just going to write that line without all the crossing out. The 1 over x minus 5 now, everything on the top cancelled. Subtract the 7 over x minus 1. So now we're in a adding, subtracting fractions land. We need a common denominator. So we're going to use a common denominator of x minus 5, x minus 1. For the first fraction, I had to times top and bottom by x minus 1. For the second fraction, I had to times top and bottom by x minus 5. You might know this technique from a kind of cross multiplying. It's sometimes called by multiplying up by the opposite denominators. It just works. Simplifying then, first thing we can't do anything with. Expanding that bracket out carefully, because that does become a plus 35 from the negative 7 times the negative 5. And even while I'm speaking, I am managing to miswrite things. And then simplify the top finally. I am going to put the number first because the number is going to end up being positive. So it's 34. And then we had 1x, so we've lost 7x. And minus 6x. And we are done. That is in its simple form. If you do want to expand out the denominator, you can. You can also factorize out a 2 in the top. None of that really makes it simpler. But if you prefer to write it in a different form, you can do. Question 22. I haven't seen the end of questions comment at the end yet, so there's at least a couple more questions to do. Question 22. We have ABCD is a rhombus. The diagonals intersect at M. A and C both lie on that line. Find the exact coordinates of the point. Okay, so this is quite challenging. The real difficulty of this question is unpicking exactly what you have to do. Really useful is to draw yourself a picture. So I have A, B, C, D as a rhombus. We have AC intersects BD at the point M, and AC is the line 2y plus 7x equals 20. Find the exact coordinates where the line through B and D intersect. Now this actually requires maybe not the most well-known fact, but it's the fact that the diagonals of a rhombus, or more generally a parallelogram, intersect at a right angle. And it's worth just double checking that fact. If I draw myself a parallelogram, oh, they don't look like they intersect at a right angle. Maybe it's only true for rhombuses. It's certainly true for kites. And a rhombus is a special type of kite. Yes, so it's not a special type, it's not a fact for parallelograms, it's a fact for kites. And if you think about exactly what a kite is, then you can convince yourself quite readily, one, that it is a right angle, and two, a rhombus is just a nice version of a kite. Okay, so we've got our idea here now then. We have, well, we want where BD intersects the y-axis, so let's try and find the equation of the line BD, which means we need two pieces of information. We need to know a point on the line, which we have, and its gradient. Well, its gradient is going to come from AC being perpendicular to it. So let's rearrange AC first. So let's subtract off the 7x and divide by the 2. So the gradient of AC is negative 7 over 2, which tells us that the gradient of BD, flip it over, swap the sign, is 2/7. That's a little saddening because 2/7 is a horrible fraction. But let's see if it ends up working. So let's go for the line BD. Now you can either use the y equals mx plus c and sub in the point. I prefer to use y minus y1 equals mx minus x1. Here the y1 x1 is this coordinate m that we have. So that's y minus minus 11 equals 2/7 x minus 6. Going to multiply through by 7. Deal with the double negatives, expand the bracket. What else should I do to simplify it? Nothing else really looks nice other than bringing the numbers to the same side. So I'm going to go back to the question. I want to find where we intersect the y-axis. Oh, that's just our y-intercept, isn't it? Alternatively, you can also think of that as where x is 0. So I'm going to do it that way. I'm going to set x to be 0 to find that y-axis intercept. So 7y plus 77 equals negative 12. 7y is negative 89. And that's not in the 7 times table. Now, there's a couple of things which I'm kind of worried about. First, let's finish the question, then we'll worry about those things. So find the exact coordinate. So it wants it as a coordinate. The x coordinate is 0. We've spotted that already. And that's our y coordinate. So a couple of things to kind of notice or worry about. Firstly, that is such a horrible answer. Negative 89 over 7 is just unpleasant. I'm going to double check. It's not in the 7 times table. It's not. It's about 12.7-ish. However, the question did say find the exact coordinates, which implies that the coordinate is not going to be nice. Which implies it's not going to be a whole number and it is going to give you a fraction answer. So that makes me a little bit happier. The other thing to think about is, did I expect a negative answer, and quite a large negative answer at negative 12? Well, A to C, and this is probably where you can draw your picture slightly better, AC has a negative gradient going through 10. So quite a steep negative gradient going through 10. So that's my line AC. M is at the point 6, negative 11. So M's down here somewhere. So BD is actually in this direction. That's my line BD. I've just turned my pen off by accident. And now it does make sense that this is quite a large negative value. It certainly has to be lower than M, and M had a height of negative 11, so it had to be lower than that. So negative 12 and a bit does seem quite reasonable. It also has a very shallow gradient, so we're not expecting it to change too much. So now I'm completely convinced that this looks like the right answer, and I'll move on happily. Question 23, still not the last question. The curve has that equation. We want to find the range of values for which the gradient is negative. Well, as soon as we see that kind of statement, gradient can mean multiple things, but this is not a straight line. So when we see gradient here, we're thinking of the derivative, dy by dx. And we've also been told it's negative, so we're working out where this gradient is less than 0. Well, that sets up our solution quite nicely. We need to differentiate first. Now be careful. This p and m are integers, they're constants, they're just numbers. So they don't get in the way of your differentiation rule. So we still just bring down the power and reduce the power by 1. But now there's just a random p in the way. The linear term, we know linear terms just lose the x. 5x differentiates to 5. mx differentiates to m. So that thing is less than 0. Well, let's rearrange this a bit. Let's try and solve this quadratic inequality. M squared is less than m over 3p. And this is where we need to be very careful. When we square roots, we get plus or minus. So our critical values, the values at the edge, are plus or minus root m over 3p. And thinking about a quadratic curve, if there are two values and we want to be less, then we're looking at this section. Oh, that's a very thick highlighter. It surprises me every time. We're looking for this part of the curve here. Made a weird smiley face there. So we're looking for x to be between those values. So the actual answer that I'm looking for is the sandwich inequality. X is between negative root m over 3p and positive root m over 3p. Nasty algebraic question, but not that much content going on there. Not a huge amount of work needed, but definitely a very deep level of understanding required. Question 24. Surely we're near the end. 25 question paper. That's more than normal. First 5 terms of arithmetic sequence, work out the sum from 50 to 100. Now we recall that we have the formula Sn is n over 2, 2a plus n minus 1d. That formula is right at the front of your book. Not needed to be memorized, but at least you need to know of its existence. But this formula works out the sum from 1 up to that value. So this, if I subbed in 100, this would work out the sum of all of the terms up to 100. So that would be what S100 gives me. However, I don't want 1 to 100. I want 50 to 100. So I need to lose a little bit at the front. And I need to lose the first 49 terms. Be careful, it's very common to subtract off S50, but we want the 50th term, so we need to subtract off S49 instead. And now it's just subbing numbers into formulas. Let's find out what our A and D are first. A was the first term, is 8. D is our common difference. We're going up by 7 each time. So the thing that we're actually wanting to calculate is S100 minus S49, which is 100 over 2. 2 times 8 plus 99 times 7, subtracted off 49 over 2, 2 by 8 plus 48 times 7. I'm going to type all of that into my calculator, making sure I've got brackets in the right places. Subtract off the second one. That's giving me an answer of 26,826. Again, useful to have some kind of context to this. These numbers are getting bigger and bigger, so I'm expecting quite a big answer. I'm adding up 51 terms. Yeah, I'm adding up 51 terms. So each of those terms are going to be pretty big. I could go and work out what the 50th and what the 100th term are to work out if this seems more reasonable. Again, that's something you can do in checking. I'm not going to do that now. Now we're on to the final question. Question 25. We can see that we've got the end of the paper comment down there. So let's do our very last question. The curve with that equation is transformed to the curve with that equation by the single transformation. We've put a negative sign in front. Well, if it's outside the function, that means it's a vertical change. Well, a vertical change with a negative sign means it's a reflection, but which axis is it in? Well, if it's changing vertically, we need to change, it's a reflection in the x-axis. Our mirror line is that horizontal line there. Reflection in the x-axis. We have a graph, a seemingly simple quadratic, and we want to draw the graph of 2 f(x) minus 1. Well, that 2 is a stretch vertically, so we're going to draw this twice as tall, and the minus 1 is a translation. Now, if it's inside the bracket, it does the opposite. So instead of being a translation by minus 1, it's actually a translation of 1. So I need to draw this exact same curve, twice as tall, one step over. So I'm going to pick out the key points. It feels like there's 5 key points on this graph. The 2 endpoints, the bottom, and the 2 roots. So let's put those in the right places. So this endpoint here was at height 3, so it's going to go height 6. It's going to move 1 over. The 2 here, well, it can't get any taller. It's at 0. Then it moves 1 over. The bottom vertex is going to get twice as tall and 1 over. It's going down to -6. The 6 root is just moving 1 over. And then finally, the point up here is twice as tall, so it moves 1 over. And again, with your pencil and ruler, you'll be able to draw this quadratic a lot smoother than I have there. Let's try that one more time. So it's a big quadratic. Let's actually hit the bottom point. The nice thing I can do is I can rub out and retry. But you'll have pencil and ruler, it's a bit nicer. Now you shouldn't do what I'm doing here, which is feathering to make it look nicer at the bottom. But that's now a very steep quadratic. We can see it's stretched twice as tall and it has been moved over 1 spot. That is the November 2020 paper complete. Please do ask any questions about it. Hopefully that cleared up some of those problems. Have a wonderful rest of your day and I'll hear from you all soon.